Sorry, guys. Okay, so we've done lots of other work to get to this point, but we are to the point of finally going from grams of one thing to grams of another thing. These are going to be long problems. You'll see there's no direct route between these two. You have to go all the way around and do all these other steps to get to your answer. These are going to be 4-step problems, which look big, but I actually think they're a little bit easier than maybe some of the other stuff we're doing, because we're just putting together all the steps that we've been doing so far. So when you read these problems and you see that you have 2 grams that you're trying to work between, you just know that it's going to be a long problem, and you're going to use all your different ratios. So let's go over it. I left this little image for you guys. So if you're starting with grams of one thing, you're trying to get grams of another thing over here, you're going to have to do one step, and then another step, and then another step, and then we'll finally get our answer after all that, okay? So we're going to have to use 3 different ratios. It's just going to be kind of long, but it's going to be okay. We'll be able to figure them out, and it will just be lots of different steps. So you guys will see that this first one, if we read it, it says, if we only have 104 grams of ALF, how many grams of F2 will we get? So for these problems, you can see that it's giving us 104 grams of ALF. We're trying to work towards grams of F2. So because we're going from grams of one thing to grams of another thing, like I said, when you read those problems, you'll just think in your head, this is going to be a long problem. So let's just get started. So let's start on our far left side. We're going to write 104 grams of ALF. Alright, so that is what we're going to be starting with over here. Now, we're starting right here on our map. So from we get to grams to moles of another thing, we're going to have to use our molar mass from our periodic table. So we're going to try to get to grams to moles of ALF. So on the bottom, you want grams of ALF. Because remember, if it is something that is directly diagonal from another thing, you cross them out. And on the top, we're going to use moles of ALF. So remember, for these, you go to your periodic table to figure out your grams of ALF. So you look and you see that, see the weight of AL and the weight of F, and you add them together. So when you do that, you'll see that you will get 45.98 grams. When you add up AL and F, that's what you should get. Then you know that since you're using a periodic table, it's for every 1 mole of ALF. Weighs that much. So far, we've just done this step right here. We're going from grams to moles. We're using our molar mass as our ratio in between. All right, so now, if we cross these things out, you see the grams will cancel each other out. So we're left with just moles of ALF on top. So if we're trying to go from moles of ALF, right here at this step, we need to change it into moles of F2. Because we're trying to get to grams of F2, so we need to change this moles of ALF into moles of F2. So to do that, we're going to multiply, and we're going to be using our molar ratio, is what it tells us, mole ratio, and we're going to be using our balanced chemical equation to figure that out. So think in your head about what you'd want on top and on bottom of this fraction. So on top of this fraction over here, you have moles of ALF, so that means on the bottom over here, we need moles of ALF to go on the bottom. Alright, so using your periodic table, you'll see that for ALF, there's 4 moles of ALF for each equation. So 4 moles of ALF is going to go on the bottom so that we can cancel it out here. Now on the top, we're trying to get to grams of F2, so we need to change it to moles of F2. So using your equation, you see that there's 2 moles of F2 for every 4 moles of ALF. So that's your equation. You'll see now we've been able to cancel out that. We'll be able to cancel out our moles of ALF. So we're just left with moles of F2. And we're almost there. We're on this last step now, going from moles to grams of F2. So going from moles to grams of F2, we're going to use the molar mass. And we're going to use that from our periodic table. So you're going to times this by, on the bottom we want moles of F2. So 1 mole of F2. Remember, you're always going to be using 1 mole of something if you're using the mass from your periodic table. It's never going to be any other number, so always use 1 if you're using numbers from your periodic table. Next, we're going to go to our periodic table. We're going to see what the mass of F is, and we're going to times that by 2. So when we do that, we take the F mass, we times it by 2, and you should get around 38 grams of F2. Alright, now we can kind of finish up our problem, and we'll see that grams of ALF are going to cancel out. Moles of F2 are going to F are going to cancel out. Moles of F2 are going to cancel out, and you're just left with grams of F2 in the end. Okay, and we're also going to go do this math down the line. We're going to multiply by 1, then we're going to divide by 45.98. We're going to multiply by 2, divide by 4, multiply by 38, and then we should get our final answer. So, after you do all that math, you should get around 42.96 grams of F2. Alright, I know that this looks hard and confusing, but let's do another one, and hopefully you guys will feel confident enough that you can kind of work on your homework by using these different steps. So, for this problem, let's read it and try to highlight our important things. So it says we want 80 grams of Al2O3. How many grams of O2 will we need? So our starting thing is the number that it gives us. So in this problem, it gives us 80 grams of Al2O3. This should be the first step. It's really easy for us. You just find what number it gives you in your problem and you start with that. Now you see that we're going to go from grams of one thing to grams of another thing. So in your head you're thinking, I'm going to be using this long process to get there. So let's get started with our process. So we start with grams of something. Always we're going to try to change it into moles. So we're right here, we're using our molar mass from our periodic table to try to change it into moles. So I'm going to multiply it by, remember I want my grams on the bottom because I want to be able to cancel them out. So my grams are going to be on the bottom, my moles are going to be on the top. So on my periodic table, I look up Al, and I see that its mass is 26.98. I look up O, I see its mass is 16. The Al I'm going to times by 2 because I have an Al2, so I'll get 53.96. And the O I'm going to times by 3, so I'm going to get 48. So then I add these both up together, and I see my mass is about 101.96. So, in my problem, I want the grams to go on the bottom, so it's going to be 101.96 grams of Al2O3 for every 1 mole of Al2O3. Remember, you always use 1 mole when you're using your grams from your periodic table. So, we will see that these grams cancel each other out, and so we're left with moles of Al2O3. So, now we're on this step right here, these moles, and we need to convert it to moles of a new substance. So we're trying to get from Al2O3 to O2. So we need to convert it from Al2O3 moles to O2 moles. And like it says up here, it says that we need to use our balanced chemical equation. So we're going to multiply we want the moles of Al2O3 on the bottom because it needs to cancel out diagonally here. So we're going to look at our equation. We see we have 2 moles of Al2O3 in our equation, so that's going to go down here. Now on top, we need to get to the moles of what we're trying to get to, so we're going to grams of O2, so we need to get moles of O2 on top. So again, we use our equation, we see there's 3 moles of O2, so 3 moles of O2 is going to go on top. Alright, we're almost there, we got to moles, so now we're going to try to go and get it to grams. So to do that, we use a molar mass from the periodic table. So we're going to multiply this by, remember on the bottom we want moles of O2, and on the top we want grams of O2. So we look at our periodic table to figure out the grams of O2, and we can see that that is going to be 32 grams of O2. Remember, look up your mass, times it by 2, since there's 2 O's. Now on the bottom, remember that's for every 1 mole of O2, because we used our periodic table. So remember, it's grams for moles. So for every 32 grams of O2, that's 1 mole of O2. Now we can finish canceling out our units. So we can take our moles of Al2O3, cancel by our other moles. We can take our moles of O2, cancel by these moles, and we're left with grams of O2. So now if we finish doing the rest of our math, you will see that we are going to get 80, and we're going to times it by 1, divide it by 101.96. We're going to times it by 3, divide it by 2. We're going to times it by 32, divide it by 1. And in the end, we should get about 12.55 grams of O2. Alright, I know that this looks confusing, so let me just cover a few of the key things you need to remember. Right now, as you're starting, I would just use this little pattern up here to go from grams of one thing to moles of the same thing. Go from moles to new moles, and then moles to grams. Alright, you'll be using your molar mass if you're ever doing grams to moles of something. If you're trying to go from moles to moles, you'll be using your balanced chemical equation. If you're not sure what to do, I'd always try to change whatever you're doing into moles, because moles will get you to something new. So start off, if it's giving you grams and you're trying to get grams of something new, change it to moles first and work from there. Alright, I know this is hard stuff, so please email me with questions. Email me if you need some extra practice or if you want me to do some more videos. But hopefully by following this little, I guess, diagram here, it should help you figure out the order of things and how to go from one thing to the next, okay? Good luck, guys. Please let me know if you need help.